Every second, millions of highly qualified professionals are actively ignored by the very system designed to connect them to opportunities. To understand why this happens, we can examine a massive Q1 2026 dataset compiled by the LinkedIn Roaster AI tool. It analyzed 500 synthetic profiles representing the Portuguese professional market. This chart shows visibility metrics for the algorithm. It reveals that 74% of these profiles have what the system classifies as low visibility. The median optimization score across the entire 500 profile dataset is 4.0 out of 10. Because the median sits so low, a mere 0.6% of professionals achieve top-tier algorithmic exposure. The professional landscape operates as a red ocean of unoptimized data, where 3 out of 4 individuals are mathematically hidden from the recruiters searching for them. Experienced, capable professionals fail to trigger the algorithm because of a fundamental strategic error. Most users treat a dynamic search engine exactly like a static paper resume. When a recruiter searches for a candidate, they use applicant tracking systems. An applicant tracking system, or ATS, is software that filters and ranks candidates based on specific keyword queries. This process relies on search engine optimization, or SEO, the practice of structuring text so that a search algorithm can easily read and index it. Treating a profile as a passive record of job history severs the connection to these active search queries. The algorithm strictly evaluates the presence and structure of data, regardless of physical competence or real-world experience. If the data is missing, the system docks the score. Failing to adapt to the search engine nature of the platform actively suppresses visibility, rendering real-world achievements invisible to the machine. This chart shows the 7 deadly sins of LinkedIn profiles. The most prevalent mistake, in 25% of profiles, is a headline limited to the current job title. This coincides with the third most common error, generic headlines missing SEO keywords. Parsing engines view the headline as the highest value real estate on the profile. Writing a generic job title wastes that space because it fails to capture specific software, skills, and metrics recruiters actually enter into search queries. Looking at raw data, when the parser scans profile LR0001 and finds a generic headline and empty about section, it drops the score to 2.0. Compare that to profile LR0028. The parser finds keyword-rich data fields, resulting in a highly optimized 6.5 score. The second most common error across the dataset is an absent or weak about section, affecting nearly 25% of the users. This introduces the concept of text density. The algorithm requires a sufficient volume of semantic context to accurately index and categorize a user. A blank summary gives the system zero data to parse. Missing metadata removes the exact hooks the algorithm uses to pull a profile into a search result, mathematically guaranteeing the user remains hidden. The algorithm evaluates behavior and time alongside static text metadata. The data shows that 22.6% of profiles have unexplained temporal gaps in their experience, and 22% haven't published content in the last 90 days. Search algorithms heavily weight the velocity and recency of data. As the days pass without new activity, a profile's algorithmic weight steadily decays. A profile treated as an untouched archive signals obsolescence to the machine. Conversely, profiles that post updates or modify their text regularly send a persistent ping to the system, ensuring they remain highly indexed. In an algorithmic ecosystem, silence is a penalty. If you stop feeding the system new data, the system assumes the profile is no longer relevant to the network. The dataset reveals a distinct pattern regarding who is failing to optimize their data. This graph shows the demographic distribution of algorithmic optimization scores, forming a distinct inverted U-curve. The scores peak prominently at the 31 to 35 age bracket and drop sharply on either end. Entry-level professionals aged 18 to 24 score poorly, despite being digital natives, as they lack the strategic understanding of how to structure a professional network. Senior veterans aged 51 and older also score poorly, struggling to translate decades of analog experience into a machine-readable format. The 31 to 35 cohort achieves the highest optimization by finding the sweet spot between career experience and systemic adaptation. Digital literacy is a distinct skill required to translate industry tenure into algorithmic visibility. While the statistics reveal widespread algorithmic failure, they also expose a massive opportunity. The 4.0 out of 10 baseline average means the vast majority of competitors are clustered at the bottom of the scale. Because most profiles contain basic, easily fixable errors, the barrier to achieving algorithmic superiority is incredibly low. Minor metadata corrections, fixing a headline, adding text density, and posting occasionally create a disproportionate leap in visibility. Achieving high visibility requires merely avoiding the unforced errors that the other 74% are making. Samuel Rollo, the author of the study, notes that applicant tracking systems and AI only accelerate the sorting process. They remain entirely dependent on the data you choose to feed them. Navigating this ecosystem requires 3 pillars: strategic clarity, digital literacy, and human awareness. Algorithmic literacy amplifies human strategy, ensuring your judgment remains the primary driver of your career. The future belongs to those who learn to speak the language of the machine without losing their strategic human intent. Your career trajectory depends on how accurately you translate real-world skills into the exact data the machine is programmed to reward. Make the system work for you before it filters you out.